Hey everybody, this is a number theory problem from Charles Vanden Eynden, second edition of elementary number theory. And this is an equation. Now, it's understood right here that, let's see here, 7 to the y. Y is understood to be a natural number, like y could be a number like 1, 2, 3, 4. It's positive integers, basically. So we're trying to solve for y where y is a positive integer. Now, this reads 7 raised to the y power divides 462 factorial exactly. All right, that's what the double vertical bars mean. Now, I've given you an example here. This is a nice example. 5 squared is equal to 25, and it divides 200 exactly because 5 cubed here does not. See, 5 cubed is 125, right? So that does not divide 200 nicely or evenly. Okay, so that's exactly what we mean by the double vertical bars. Okay, it was an important enough symbol, or it came up enough to where they actually created this special symbol for it. Okay, now, so we're supposed to effectively count the number, the multiples of 7, or the number of factors that are multiples of 7 in 462 factorial. And what I've done here is I've listed out some of the, I guess, more important ones. There's 7. Now notice I didn't list numbers like 14. You really can't. I'm trying to be practical about this. 14, 21, 28. They're all multiples of 7. I listed 7, and of course 7 squared is a multiple. And then this 343 is 7 cubed. 7 raised to the third power. 7 times 49 times 7 times 49 is 343. Okay? But understand there's a lot of multiples of 7 in here that I haven't listed, of course. 81 would be an example, 63 and so on. 90. Or not, excuse me, what's one bigger than 105? There's a lot, okay? So we need some sort of formal type of machinery to count these multiples, and there's something called the floor function. I guess a lot of you are probably familiar with the floor function, and I'm gonna write that out here. Again, y'all, we're trying to count all of the multiples of 7 in the expression 462 factorial, and that will be y. Okay, so let's go ahead and try to manage this here. So you guys perhaps have seen this. This is called the floor function, and it returns an integer. It always returns an integer, and you can think of it as a rounding down function. And so we'll start with 462 divided by 7. Okay, 462 divided by 7. Okay, now okay, now let's see here. 462 divided by 7. I believe that comes out to be exactly 76. And so the floor function does not do anything. There's no fraction to chop off here. Is that right, folks? 7, let's see here. 76, 60 times 7 is 420, and then another 6. I'm using my calculator off to the side here, folks. So it's 76, right? 7 times, no, let's see, I think I made a mistake there. Let me erase that. Let's see. Y'all, I don't have the calculator handy here, but I believe that would be, let's see. Okay, that's 66, excuse me, 66. All right, folks, 66. Again, 7 times 60 is 420, 7 times 6 is 42. So this is correct, and there's no rounding actually going on right here. Okay, now, there's 66 multiples of 7. Now notice that would only count this one once, and it would only count this one once, all right? So now let's take a look at the next one, 49. So we'll have 462 divided by 49. Now, that, it doesn't quite make it to 10, does it? Because 10 times 49 would be 490, right? So this is going to be equal to 9. You know, that's the nice thing about the floor function. It just chops off any fractional piece. And again, folks, you can see that 9 times 49 would be what? 360, 341. And so this would actually, right here, the 462 over 49 would actually, I'll just write this out for you, 462 over 49 would be equal to, it's going to be a mixed fraction, of course. So we'll have 49 is equal to 9. And then plus 21. I'll go ahead and put the plus there. Normally on mixed fractions you leave the plus out, but it's understood operation. I believe that's 21. Okay. That's exactly what the floor function does. It just gets rid of the fractional piece. It rounds it down no matter what, really. Perhaps is a more accurate way of putting it. You don't ever round up with the floor function. It just maps to the greatest integer less than the input argument. And y'all, I think I got that right. 9 times 49 is 360 plus 41. That's 441 with 21 left over, right? And so what happens here is that the only thing the floor function cares about is the non-fractional part. Okay. So there you go. So far we have 66 multiples of 7. And again, this picked up the multiples of 49 that weren't counted in this count over here. Okay. And then now we have 9 multiples of 49. That's exactly what this, y'all, this reads 66 multiples of 7. 66 multiples of 7. Let me write that down. Multiples. I'll abbreviate multiples, M-U-L-T. Multiples dot abbreviated multiples of 7. Okay. And of course this would be multiples of 49. Okay, now let's go. There's one more here. Remember, we got to handle the 343, which is 7 cubed. And so let's create a little more space here with this nice AirMac trackpad. So right here, folks, we have 462. Y'all, I just switched platform. This is really nice. It's really nice using the AirMac instead of the old beat-up Hewlett-Packard I lived with for a long time. 462 divided by 343. Now that's an even easier one to see without doing too much heavy lifting. Okay, now that's clearly just equal to 1, right? Ladies and gentlemen, we don't have to do anything at all on that other than notice that 343 goes into 462 just one time, and that's all we care about. So there's one multiple of 343 in that whole expansion. So folks, what we get is our y is actually going to equal to the sum of all of these multiples of 7. So that's equal to 66 plus 9 plus 1. And y'all, I can do that in my head. That's 76. 66 plus 9 plus 1 is 76 without a calculator, right? We can handle those double-digit sum ends. So we get 76. And that is the solution, folks. 76 is the final answer. And if you scroll back up, let me scroll back up right here. We got the 76, and that is the y. Whoops. What happened here? Did the track thing mess up on me? Yeah. So right here, folks, y is equal to 76. I think I lost my marker here. So we get y equals 76, final answer. and I'm pretty happy. It's better on me. You guys probably don't like me going all over the place, but it's a better pen. Everything's better about this. This thing has its own screen recorder. I don't have to use Zoom anymore. It's really nice. Expensive, but nice. Okay, y = 76, final answer. Let me know what you thought.